Hello, everyone, and welcome back to Big Data Days 2024. And on this next hour, I have two very seasoned and good speakers for you. We're going to be listening to Michael John Pena and David Ding, and David Ding is going to do the first part of the presentation. David is the director and lead data consultant and is a certified fabric data engineer, data and AI developer with a master's degree in data science. Previously, David held multiple senior business and technical positions. His book on Power Platform is part of his mission to help everyone get better with data. And today, David and his colleague are going to talk about supercharging large language and models and generative AI with retrieval-augmented generation and vector databases. David, I'm really looking forward to your presentation. Thanks for being on the first time Big Data Days with us. Floor is yours.
Thanks, Jen. Thank you for the introduction. Before I actually get into the actual content, just sharing a personal story with ChatGPT. We all have our own kind of engagement, like highlights with the tool. I think most of us do. What happened with me is this is back in February this year when Microsoft just released the Copilot. My son at the time, he's doing his cello lesson, and I was just waiting for him. I'm playing around with Copilot on my phone. There's one app in there. It's called Sono. It's a tool which allows it to generate. I can talk to it, ask it to generate music. So I did exactly that. It generated music. It actually included lyrics. I asked it to change it into a rap. It did that as well. And at that point, I'm wondering, why is my son learning cello? And a few months later, to this day, I still haven't quite figured out the answer to that one as yet. And that is partly because the LLM technology is still evolving at a massive, crazy pace. For anyone who's, I'm sure the other presenter have mentioned as well. So this morning or last night, depending on which time zone you are, OpenAI just released the new ChatGPT 4.0 Omni, and it is incredible. What it did is actually mixed visual and text, audio and text, and also just the large language model, combine it together in a very intuitive way that gives you a kind of a real life personal assistant. I tried it a little bit. It really blew my mind. So this is where everything is evolving so fast. We don't know exactly where it's going to land. Maybe one day we will have artificial general intelligence that surpass, what our brain is able to do. But to this date, there are still a lot of limitations. And one of the one that's quite relevant to our conversation today has to do with the actual memory of these large language models. So before we get into that, Michael and myself, we've covered a lot of grants in the past 10, 15 years, both really excited about, sharing our learning while practicing a lot of different things, experimenting with latest technology. It's a fun space. It's an amazing space. And there's so many people that coming into this journey with the open source community side of things as well. So it's a very, very exciting time to be in tech. With that, just take a step back and just look at large language models in general. So when we talk about large language models, we're talking about a type of artificial intelligence that can process and produce natural language text. This is probably an understatement. One thing that's with this natural language, once the computer is able to understand, is able to master natural language, it seems to give it additional capabilities other than just talking to human. For example, it is able to reason. and it is able to apply logic in a given context. And that's coming from a massive amount of training data to actually help the large language models to provide that overall context. And when you look at large language models, a lot of the time we'll hear about the foundation models, whether it's ChatGPT 3, ChatGPT 4, or Llama, etc. So these are particular model architectures. They mostly based on neural network, but the layer and the structure of it is actually quite complicated and extensive. We're talking about potentially hundreds and thousands of layers with some of the foundation models. And we're also talking about a large number of parameters to provide that context with it as well. So how do we know that the model is good? One of the more objective method of measuring it is to allow the model to actually sit in different tests. We have AP biology tests, uniform bar exam on the legal side, reading and writing tests, math tests, etc. And you can see this is the result for ChatGPT 4, which is almost 1 year old now, and it is just smashing a lot of the test scores here. And while what you can observe from this one is that for anything to do with memory, obviously computer can memorize things a lot better than what human can do, even before some of these large language models. But also in maths, that requires a lot of logic and context around solving math problems is doing extremely well. And also creative writing as well is also doing extremely well. When you look at the results, so when it says 88, for example, for LSAT, it is saying it is doing better than 88% of the participants. And I assume most of them are still humans. So, since ChatGPT was released back in the day, we have an explosion of new models coming into the market. Some of them are, really well known, but there's tons of them that we haven't heard of. The more famous ones, probably one of the most performance-wise that's on par or even succeeding ChatGPT 4 is Claude.ai. So, and then there's obviously the Gemini from Google, Llama from Facebook or Meta, Microsoft. As you can see that everyone is trying to compete in this space, trying to do their own research, and based on the research, come up with their own model as well. And it's such a crazy space. Michael and I has been actively trying to follow what's happening, and it's actually really difficult to actually keep up to what's going on in this particular space. It's both exciting and daunting from a developer perspective. And this is one slide that bring us back into the enterprise data world. Before we kind of talk a bit about the different large language models, kind of give you an overall flavor of what they can do and the massive development since ChatGPT 3. When you try to use the LLMs in such as ChatGPT in an organization, it's quite often a very different story. For one thing, a lot of organization prevents you from accessing ChatGPT, for example, because companies are worried that you might accidentally send some sensitive information online, personal data or company username, password type of things onto the internet. So a lot of time they actually prevent it. So what you see, this hierarchy is a what we call a co-pilot hierarchy of needs and wants when it comes to the organization. At the bottom of this, you have this personal exposure. This is what I do a lot of the time with some of the clients at the moment. So I'm a developer. I use Python on a daily basis. Some of the clients don't allow me to use their laptop to actually connect to ChatGPT. So I'll use my phone to ChatGPT, get answer for like code suggestions. How do I optimize a particular machine learning model, etc. And then I'll send that some of the code to my work email, and then I'll use it that way. So that's the personal exposure. One step better is the group consumption, where the company actually sign up to enterprise licenses. They found a way to actually prevent the data from being sent to just public internet in a kind of secure environment. I can still use, engage with large language models but with a very limited kind of risk factor in there. But still, we're talking about the foundational large language models here. We haven't been able to actually bring any company data to this to the large language model as yet, and that is where the next step comes in, where we actually try to connect to the company data. And the most common method for connecting to data is Retrieval-Augmented Generation, which we'll spend more time a bit later on to actually talk about. But just in terms of the hierarchy, once the data, you have been able to connect to the data, typically when you do the proof of concept, after the initial excitement dies down, you will notice that, well, the answers is not always as the way that you wanted it to be. So there requires a bit of fine tuning, and that's where the enterprise ready stage come in. We're not just talking about like concepts here. We're talking about investments in infrastructure, in skill set, etc. So at the top end of the pyramid, we have a full scale deployment, actually potentially retraining the entire large language model using your own data, using your own experts to moderate the actual result and provide feedback. So it doesn't mean that every organization needs to go all the way to the top. You know, the top is typically OpenAI, Microsoft, those large organizations who's got the skill set and also resources, very importantly, to actually do these things. For most other organizations, we'll be looking at the enterprise-ready layer or the connected to the data layer. And to this date, very few organizations has been able to successfully connect their data, and that's where RAG really comes in to help. So just at a high level, if we actually look at the process flow, if you forget about RAG for now, just normal LLM, from a user perspective, we assume that we're just talking to the large language model. But in fact, what we are talking to is a user interface, or what we call an app. So all the chat experience, you type something, you see something back, that's handled at the app level. And does that mean the app talk directly to the LLM? No. In fact, there's a layer called orchestrator. Orchestrator is actually a very important layer that helps to optimize the compute resource where the LLM is sitting. It also provides context. You can run prompt through the orchestrator to help you to improve the overall engagement with the LLM. So it is the orchestrator that performs the job to engage with the LLM. So we talk about memory at the very beginning. So the way that for large language model, how memory works for large language model is, at least for the paid model, this model get trained on a regular basis. It could be weekly, it could be monthly. It will continues to bring new information in, and it will retrain the model on a regular basis. This is actually quite different to how humans operate. For example, you attended the session today, and there's a particular speaker. There are certain things in there that you really enjoy, and you listen to it. You actually memorized it, and a friend asks you a question 5 minutes later. How is the session? You can go, yeah, it is great. This is what the person actually talked about. I call that dynamic memory or auto memory. That's not how LLM operates. So LLM does rely on that repeat training to actually absorb new knowledge. So that's the limitation for these foundation models. And what we want to do here is to introduce a new knowledge store. So this is the company data in our scenario. Or if you're using it personally, it could be your personal email that's creating this knowledge store, which is separate to how to the knowledge store for the large language model, in fact. So the orchestrator now have this task to ask the question either through the LLM memory or through the newly created knowledge store. Typically, they are stored in different databases using different designs and embeddings. So these two knowledge base can't merge, and probably for good reasons as well. So the orchestrator actually can't communicate directly with your knowledge store. You actually need to do it through a search function as well. So you can look at the search and knowledge store as a separate LLM in this case. So the orchestrator is kind of talking to a foundational large language model as well as a very specialized large language model that contains your own company data. And the orchestrator through prompt will actually construct the actual response based on the user question and feed it back into the app. So that's at a very high level how retrieval-augmented generation works. And as you will see, the orchestrator plays a fairly crucial role to the actual user experience here. One of the most common orchestrator is done by LangChain. LangChain is a platform that you can actually use it for many different purposes. But in our scenario, we'll focus on the orchestrator function that it can perform. And before we get into that one, just want to quickly talk about the hallucination problem. Hallucination is a very common behavior of large language models. I wouldn't call it necessarily an issue because this happens when, let's say, you ask the same question to the same large language model 100 different times. It will not give you the same result over those 100 times. It can give you 50% of the time something that you are expected, but every now and again there's could be an error or you start go down a slightly different path. So that's the hallucination, and that's because just the nature of large language models being very difficult to predict. I would often compare this with SQL query. If I write a SQL query and then I get an incorrect result, what I need to do is just to go back to the SQL query, modify it, and by the end of it, I can get the right result. But I can't do that with large language models, unfortunately. So the orchestrator, one of the very important job is through prompt and various other techniques, it can actually help to reduce hallucination. It cannot, unfortunately, completely avoid it, but hopefully you can actually bring it down to an acceptable level. LangChain, it's called LangChain because from a developer perspective, it's actually really developer friendly. I can take different actions and kind of combine them together step by step to go from input to output. Connect the LLM, do the embedding steps, etc. in between. So it's from a development perspective, it's actually very well designed and development friendly. And the other benefit of using LangChain orchestrator is just the fact that it's got a large community already, relatively speaking. And if there is a problem, if I face a problem, I can actually search it online. The online community is quite active. I can either find find the answer to my a similar question already, or someone can actually answer it. Let's face it, from a developer perspective, these days, nobody really relies on the vendor support anymore. So having a active community is actually really critical to the success of any projects you're working on. So obviously, other than LangChain, similar to the foundation models, there are so many different options as well. GPT, OpenAI has got its own. Semantic kernel is one done by Microsoft, which is quite interesting as well. And I also want to quickly mention about Hugging Face. Hugging Face, through Hugging Face, you can actually get access to a lot of the academic, so a lot of large language models used in academic papers. So it doesn't necessarily have all the the latest, the best. But if you are able to actually want to get an understanding of how things work, you can often find what you need through Hugging Face platform. So,
David, do you want me to continue?
Yeah, sure.
Yeah. Hi, everyone. So now let's talk about this knowledge source, right? And there are a bunch of different, knowledge source out there and emerging approach as well. So if you go to the next slide, we, talk about different strategies out there around data chunking. We're in different strategies in place already about how you can organize your RAG pattern. Things like within the Azure ecosystem, you have AI search that does a lot of this automatically for you. You have a data source, let's say a storage or a SQL database, and then you can kind of integrate that with, with your LLM using a search capability with Azure AI search. Okay. The thing though is that in the important aspect with RAG, or kind of the biggest challenge there is that you're trying to solve the hallucination problem. Now you will be facing a different problem, which is how relevant is the information being thrown back to the user, or how how semantically accurate are you trying to convey the intentions of that user. So things like that's just becomes things like data chunking and the whole concept of automatic flow. What if I have new data source, and so on and so forth. That just becomes another strategy in place for that one. Next slide, please. All right. So there are a lot of options out there, right? Because again, this is the early days of this technology. So things like vector database is the primary kind of contender out there. There's also graph databases. with Neo4j and stuff like that. But with vector databases, there are like a lot of options. Things like pure vectors, like native vector databases like Pinecone, Milviews, Chroma. There's so many out there at the moment. Quadrant is one of the kind of like leading pure vector database as well at the moment, who receive massive funding. And then there are also other databases like Postgres or MongoDB who are not traditionally working on vector, but they became, they had extensions to support that capability. So that's also, one thing to look at. Right.
Just quickly to mention as well, while this may look overwhelming, but depending on your current data storage and your current stack, tech stack, it kind of almost narrow it down to only a few options as well. So in practice, it's actually a bit more manageable.
Yeah, exactly. Right. Now, let's go to the next slide. Okay. Now, I mentioned earlier about the importance of relevance and quality, and how do you actually kind of like, as we keep on saying, right? Now you have a very powerful beast out there, which is the LLMs. Now, how do you ensure that whatever it's spitting out is relevant or of quality? And again, there's so many approach out there that can enhance that. Can you go to the next slide, please? So with RAG, things like, this could be one of the stacks that you can use. Things like having LangChain as an orchestrator, then Azure AI Search as your kind of like search capability, and then Azure Storage as your data source, and using GPT-4 most likely with Azure OpenAI for your LLM. And there are a lot of different varieties of this, right? Like you can have like semantic kernel as well. As an orchestrator, you can have like Quadrant or Chroma as your AI search, and as a replacement for AI search. And you can use things like Llama as well, or Mistral. So many models out there. Actually, I just looked at AI Studio earlier. There's actually 1,635 available models to play around these days. So many options. Next slide, please. Okay, now because of this kind of like evolving sphere, a lot of these major clouds, they like, you might already have some cloud applications out there, like already deployed on cloud. Now you're just looking for ways to extend this capability. So in the Microsoft world, you probably want to, mix the, ecosystem between Microsoft Fabric and Azure OpenAI, or Azure AI Studio. So that's why things like Fabric works hand in hand with AI Studio, and like Fabric mostly works around like having a clean data sources or clean data for you. It avoids that whole garbage in, garbage out concept. And then you have the Azure OpenAI and AI Studio on the other hand, that allows you to have a lot of these generative AI capabilities on the other hand. And again, Microsoft is a kind of like a leading in this space because of that kind of like deep partnership with OpenAI, and we know where OpenAI is like the dominant player in the space at the moment. And that's why, working this on an enterprise landscape, there's a lot of that value add within the ecosystem of Microsoft. But then if you're in the AWS land, all right, again, there's a lot of options out there as well if you're in AWS. But one thing that really kind of like resonates with me lately is that Claude, the model, Claude 3 Opus, is a very powerful model. And they have a partnership with AWS. And you can use that with, Bedrock, which is like their kind of like ML platform to allow these capabilities. And if we go next, with Gemini, GCP as well, you have this Vertex AI stack, things like having Vertex AI datasets all the way to like deploying this through a Firebase ML, TF Lite, TensorFlow Lite, export to your Android device, right? So there's also a lot of things happening in this space, not just on, OpenAI and Microsoft. So that's why it's a kind of like interesting space to look at. That there's a lot of techniques that can improve these capabilities. And I guess where this all might be going and where this is starting to go now is the concept of agents. And with agents, it's more around like customization. Like it's not just about chats anymore. It's we're introducing modality now, like voice. We're doing videos. We're doing speech and translations, and it's not just about question answer forum anymore. There's like agents capability now. Like there could be an agent, like a master agent, who you're going to talk to and say, hey, generate this report for me for the whole fiscal year, right? And then under the hood, that master agent can talk to a bunch of like different agents as well, to kind of like form that task, which is create the master report, right? So it's going to come to that point in the future now that a lot of this kind of like single task, or for those who are in the software development world, like a microservice or a micro agent capability, like just specifically doing this task, they now become servants to a lot of these conversation, like master agents or things that the actual user are talking to. So this is where this is all going. So in the future, like it's gonna be capable of like doing much more complex tasks, because it's literally scaling. Instead of just having one model to do everything, this is literally supercharging that LLM with a lot of those different avenues and capabilities to look at. And I think things like autogen is something to look out for.
Yeah, 100%. I mean, we have kind of experimented with a simpler version of this thing where we have a agent that's LLM that's kind of specialized in querying the existing database of a organization. So that's one way kind of to limit the hallucination problem, and then the master agent can kind of help to construct the overall whether you want to report or strategy type of thing. So it's a very interesting space indeed.
Yes. All right. So I guess in summary, do you want to summarize, David, for us, please?
Yeah, sure. Thanks, Michael. So we've looked at the large language model, how we had so many different things since ChatGPT 3. We talk about the memory limitation of those foundation models and how RAG is the best approach to actually take your own data into that LLM chat experience. We look at the orchestrator and how it is important to use that to with the overall reasoning and the user experience side of things. But very importantly, when we do decide to adopt RAG, then vector database and the various different options that you have to actually consider, and also let's face it, LLM is not built for small machines. We're talking about like cluster of servers to be able to actually achieve some of the compute that's actually required for good user experience as well as storage. So I definitely hope you find this session interesting. Is there anything else you want to add, Michael?
Well, I guess really, you might see where this is all going in like real world experience, right? I think a lot of the emerging problems that I see still as a consultant is that a lot of organizations are not yet ready for this, because like they still have a lot of data issues, like data governance issues. Like they don't even have a team. They don't even have a panel to look at this. Like they don't have a CDO, a chief data officer, or like those type of things. Like I guess where a lot of this bucket falls under these days is still on the application side of things. But I think ongoing, as we mature, with this, there will be a lot of emphasis about data governance, domain stuff like data mesh architecture, things like separation of duties and things like that. And responsible AI would be key as well, right? So I guess a lot of those underlying enablers or disablers at the same time would be kind of like what's moving forward or backwards with a lot of these initiatives.
Yeah, challenging times ahead. Like everyone is kind of playing catch up to a certain degree at the moment. So yeah, no. Thanks, Enterprise Big Data Framework for organizing this amazing day. Yeah, thanks, Michael.
No worries.
It's working with you on this as well.
Thanks so much, David, and also Benya. Thanks so much for joining. Very interesting session, which kind of gave us, I would say, a deep dive into more of how LLMs were developed, and also the challenges in the design process. A lot of questions came in during the session, so we still have some time. So if it's okay, I'm going to moderate a few of them. For everyone who's listening live, note that you can still upvote or downvote questions that you'd like me to cover. There is too many to discuss today, so I'm going to send over some of those questions to David, Benya after the session to maybe ask separately one-on-one. But let me moderate some. The most voted up question is, I think, a very interesting one. I'm going to project it on the screen right now. It says, do you feel that coders are in the same boat? For if someone went to school for coding, would you have the same thought about them learning to play the cello? This is for Mr. Dean.
Yeah, very good question. There's a lot of things that I think it's going to have a lot of impact on how we learn, what we learn. Is the current education system still going to be relevant if we're going to have a personal agent next to us helping to answer our questions, helping to us make better codes, or even just code based on our own ideas? I would probably refer to what the CEO of NVIDIA said, that I think there are so much different space that we can explore, human brain, how human and other species actually age, the aging problem. We can explore the universe. There are so many different opportunities out there. If we stop thinking about our current job and kind of embrace the future, there's actually endless opportunities. And in terms of programming language, his view is that the English or any language is actually the best programming language moving forward.
Good. I like that. I think that's a very great quote to use for the rest of this conference. During this conference, we also have obviously the opportunity to ask some more technical questions because we have a lot of, I would say, subject matter experts listening. So I'm also going to go that route for a quick second. Next question is from Shurab. Can you talk about the resource intensiveness of LLMs and RAG, GPU, and memory?
Right, I can probably take this on. So the thing with LLMs, I think there are different aspects of this. Shurab, I think the two important aspects that you have to look at is the actual training of the LLM and the inference, meaning consuming or deploying it and consuming it, right? So we've established that training an LLM or just building an LLM is already very resource intensive. As mentioned earlier, you need clusters of GPUs, data center worth of GPUs just to get there. Even to the point of just fine tuning it, like just let's say adding 2 gigabytes of your data to a GPT 3.5 model would take you a lot of resource already to get there. And most likely you don't want to do it on-prem. You probably want to do it on cloud as well. There are options, but it's a bit costly, right? That's why RAG is kind of like an approach wherein use LLM as where it's good at, which is talking and making sense of what you're intentions, and using RAG to kind of like ground it to your data, meaning your own data, like making sure it's talking about whatever your intent is. If you're talking about healthcare, it should just stick to healthcare. If you're talking about your company, it should just stick to your company. So I think those are like really the most important aspect to consider when planning, resourcing, and pricing with these things. And not to mention LLMs as well, they're not priced the same. So a Falcon, a Llama, a GPT-4, they're all priced different. So you have to consider them as well.
Good. I'm also going to use a question which is kind of referring back to my keynote from this morning. So that's why I'm obviously going to pick this one. And this question is coming from Katina. And the question is, we talked about synthetic data during the opening of the conference. What are your thoughts on synthetic data to train LLM models? That's kind of the big question of today.
Right. I can do a 1 minute spiel, then Dave, you can follow up. Okay.
Yeah, that would be great. Okay. Let's hear it from Michael first.
So because like earlier days, around 2014 to 2017, I actually worked on blockchain technology. So I'm also opinionated about provenance and like synthetic and like the whole concept, like what is yours and what's not yours and stuff like that. I think my general answer is that things like large language models, if you're paying for it, right, they shouldn't be using your data to train the service that you're paying it for, right? That's just at least one philosophy I follow, right? If I'm paying for something, I'm expecting for something as part of that, and don't steal my data as part of it. And then second is that if I'm paying for it and you're making money out of it, you need to pay someone based from the money that I gave you. So, and that's where that synthetic data would probably fall in that provenance aspect of like, oh, Dave wrote a blog post in 2018 about the best recipe about a mojito, and like when I talk about like, hey, can I get the best recipe in mojito? So somehow Dave needs to be compensated for that. And again, that's just my approach on this, or my philosophy around that.
Good. Thanks, Michael. I think that's a very clear approach. David, your thoughts?
Yeah, I completely agree with Michael on that. I think there's always a short-term perspective, a medium-term, and a longer-term perspective into the future. And it's really hard to say what the long-term future looks like, because, like I mentioned, exactly where we're going to end up, nobody knows as yet. I sometimes look at this from the way that I learn things. I read a blog about certain problems, let's say Power BI DAX or Python problems. I learned it, and then I kind of figure out this is how it works. Came up with a business problem. I then applied what I've learned, and I think to a certain degree that's what the large language models are doing as well. What does that mean to say that I should be paying for the people who wrote the initial blog? I think they should be paid, but the method of achieving that could be a little bit more challenging. Yeah.
Well, I think that's a great understatement to end this session. Very complex and something I think of which we have not seen the last discussion. We're almost out of time. There's one question that I think is on everyone's lips, especially today. Just keep it very brief. So let's do just 1 minute each. Let me start this one with David. Your first thoughts on GPT-4o?
I always look for that the movie Iron Man Jarvis experience. And I think we're getting closer and closer as we go. I'm really looking forward to having that personal assistant to help me to be even more productive and be able to actually achieve more in the next 5 to 10 years.
Great, thanks, David. Michael, your thoughts?
No better way but to actually try it. I literally spent my whole morning just playing with it, and I'm hooked. This is like Siri times version 100. I talked to David earlier. Like this is it. Like you want a conversation where you can interrupt, the flow, and like you can modify it on the fly. You don't have to always wait for the response, because as human nature, we're kind of like impatient. We always want to, this, and this. So I'm just amazed. Again, for everyone, just try it out. You'll be surprised how amazing this technology is.
Great. Thank you. On those very interesting words, I think we're going to close this particular session. But the good news is that our next session is already right around the corner, exactly 15 minutes from now. And here we're going to go into what is always one of my favorite areas of our favorite sessions during the day, which is the panel discussion. And we're going to see Michael actually back here. So Michael is going to be on the panel together with Ashutosh Yadav, who's the lead architect of data analytics practices at CloudTech, Valeria Sudievsky, who is the technology strategist at Microsoft, and Kate Bone, who's the BUPA Every Woman in Tech Leader 2024 and European Woman in Finance and Excellence in FinTech. So we're going to be discussing in the next hour AI-powered digital transformation, which I think is a topic which is on everyone's minds these days. And I'm super excited to be sharing the floor with these 4 great panelists to kind of pick their minds and brains around what is going to happen next. But before we go there, I would like to thank David and Michael for their wonderful session today. Thanks for being on Big Data Days for the first time this year. So it's been an absolute pleasure to host you.
Thanks, John.
Thanks, John.